So welcome back. So in the last class we have derived this equation, okay, in which generated we have generated the relation between the body frame, the body frame of the DDR robot, differential drive mobile robot, and the absolute frame, okay, and we have generated this relationship and how this mathematical equation is coming, how this mathematical matrix is coming, we have discussed in the last class. Okay, so go back in my previous video and see how this is coming. This is very important relation, okay, for this differential drive mobile robot. So in this class we will solve a numerical problem, okay. So how numerical problem may arises, okay. So when you will solve this numerical problem, you will it will be more clear, okay, you will be more familiar with various situations, various problem. Okay, so let us start. So suppose this is a DDR robot and this is absolute frame, and as I have talked in the last class that two type of sensor are used in this DDR robot. First is the heading sensor. The heading sensor gives us the direction of the robot, that is theta, and the other sensor is encoder. So incremental type encoder is used here, okay. So now the problem is that suppose a encoder is placed here, and now this encoder is generating 500 pulse per second, okay. If in question it is not given that which wheel is generating this pulse, we will consider that this pulse is same for both wheel, okay. But if it is specified that this pulse is coming from left wheel or right wheel, okay, then accordingly we are to solve this problem, okay. Now when it is not given, then we will consider that both wheel is generating same pulse, okay. Now this is the problem. Now what we need to find? So we need to find out the linear velocity of DDR, differential drive mobile robot, with respect to absolute axis, okay. Means we need to find out the absolute velocity, okay, with respect to absolute x-axis. Means we need to find out this, okay. So for that we have this equation. So for that we have Vx equal to what, okay. If you will solve this, so you will get r by 2 cos theta into WL plus r by 2 cos theta W by R, okay. So or we can write, if both wheel is generating same pulse, okay, means angular velocity will be same for both wheel, okay. Means in this case WL is equal to WR, okay. Now this will become R, okay, R cos theta into W, okay, equal to W, okay. Now Vx, okay. Now from this equation we know the value of R, and suppose R is what, R is 10 centimeter, okay. So we know the value of R 10 centimeter, so we can convert this into meter. So 10 by 100 meter, okay, 0.1 meter, 0.1 meter, r cos 50 degree. Now we need to find out this angular velocity. Okay, but here this is angular velocity. Omega is what? Angular velocity. So but here we are getting the velocity in term of pulse. Okay, for that, now for solving this we need to know how encoder work. Okay, so now we are to convert this pulse value, okay, into angular velocity. Now so for solving this we need some more information. Okay, so I have just taken this question randomly. Okay, so when you will get this question, you will have some more information about the encoder. Okay, so let me a little bit talk about encoder. Okay, so this is encoder and this is the slots. Okay, the encoder for incremental encoder. Okay, now when this encoder is fixed with the wheel. Okay, and when this encoder rotate, okay, there's a light pass through this slot. Okay, due to that a pulse generate. Okay, so suppose number of slot, okay, suppose number of slot is 50. Okay, number of slot is 50. Okay, now when this is rotating, okay, so when 50 slot will pass, it will this wheel will rotate by 1. Okay, means it is generating 500 pulse per second. Means what? Means 500 divided by 50, okay, equal to 10. Means 10, okay, 10 cycle per second. Okay, means 10 cycle or 10 round per second. Okay, or rps, okay, round per second. Now we will convert this rps to rpm. So 10 into 60, 600 rpm, round per minute. Okay, now we will convert this rpm into rp, or angular velocity, or radian per second. Okay, angular velocity is in rad per second. Okay, so for that we have formula omega equal to 2 pi n by 60, or if we will, so this n must should be in rpm. Okay, this will be 2 pi n is 600 by 60, 10 20 pi. Okay, now 20 pi is rad per second. Okay, so in this way we got the angular velocity in radian per second. Now finally we will put this value here. So we have 0.1 cos 50 20 pi. So finally by solving this we will get 4.38 meter per second. Okay.